Hi, Math 2 Enhanced. This is page 10 of our packet, and we're going to talk about complex numbers today and our imaginary numbers. So to start off, what are complex numbers? Well, complex numbers are numbers in the form of a plus bi, where a is my real part and bi is my imaginary. So this might look several different ways. For example, 5 plus 3i is a complex number. 5 is my real part, 3i is the imaginary part. Negative 2 plus 2i is, the negative 2 is the real part, the plus 2i is the imaginary part. 3 plus or minus 5i, 3 is the real part, the 5i is imaginary part. So what is this imaginary number? Well, I squared equals -1. So this imaginary number isn't a variable, it's I. And I squared is equal to -1. So you can imagine that if I took that statement, I squared equals -1, and I took the square root of both sides, the square root of I squared is I. And so now I equals the square root of -1. So all of those square roots of negative numbers that we thought had no solution, now will have a solution, and that solution will be an imaginary number. Let's take a look at a few examples of simplifying square roots. In person, in class, I also did a very short lesson on simplifying square roots. So if you have trouble simplifying a square root, please come see me during office hours so we can do a little background on that as well with you. So, for example, let's look at perfect squares that are negative, such as the square root of -9 and the square root of -25. We already know that the square root of 9 is 3. So in this case, this is the square root of -9. You can think of this in your head as the square root of -1 times 9. So the square root of the 9 is 3. And the square root of -1 is I. So this equals 3i. We would always write the I behind the 3. We wouldn't write I3. It wouldn't be wrong. We just don't write I times 3. We write 3i, the 3 in front. So why don't you think about what you think the square root of -25 would be? Were you thinking 5i? So the square root of 25 is the 5, and the square root of -1 is I. So these square roots were problems that I could completely take the square root. What if my number isn't a perfect square? For example, row 2. What if we have something like the square root of -17 or -21? In these cases, 17 isn't a perfect square. It doesn't have a factor that's a perfect square. So I cannot take the square root of -17. I, however, can take the square root of the -1 that's in there. The square root of -1 is I. So I'm going to pull that I out in front, and I'm going to leave the square root of 17 alone. It's I times the square root of 17. Same thing with the square root of -21. -21 only have the factors of 3 and 7, or 1 and 21. There's no perfect squares to simplify. However, this is -1 times 21, and I can take the square root of the -1. It's I, leading me to get I times the square root of 21. So what about square roots that do somewhat simplify? So for example, the square root of -12. This is the type of problem we did a little extra work with in class. So if you need the support, please come see me. So the square root of -12, I think about this as being -1 times 4 times 3. So it's the square root of -1, the square root of -4, and the square root of 3. So the square root of -1 is my I, the square root of 4 is 2, and the square root of -3 is something I can't simplify. So 2 times I times the square root of 3 would be the more simplified version of square root of -12. Let's try this again. How about the square root of -50? Again, I need to break my 50 down into factors. You're welcome to think 5 and 10, but this goes back to the extra work I did with kids in class. A much quicker way to simplify this in my mind is to think of this as -1 times 25 times 2, because 25 is my perfect square. So the square root of -1 is I. I'm going to pull that outside. My square root is I. The square root of 25 is 5. I'm going to pull that out in front. And the square root of 2, I can't simplify. It would stay underneath the square root. Again, if you find that you need more support for simplifying square roots, please come see me. So complex numbers, we also add them and subtract them. Addition is generally pretty easy because it's simply combining like terms. Let's look at an example of that. I have 3 plus 4i plus 7 minus 2i. So in this case, I can add and subtract integers, and then I can add and subtract my imaginary terms. So in this case, the 3 and 7 are like terms. I'll be able to add them, and I get 10. The 4i minus 2i are like terms. I'm going to be able to combine them and get 2i, positive 2i. My answer is 10 plus 2i, the 10 being my real part, and the 2i being my imaginary part. So what about subtraction? Subtraction is where sometimes we make a minor subtraction mistake. So let's take a look at that. So 3 plus, this is my second example in this box, 3 plus 4i. We'll use the same complex numbers as above, but we'll subtract them this time. So when you subtract, you need to change it to addition by distributing the negative into your parentheses. And my number one tip, drop your parentheses. Drop those parentheses so you don't accidentally change it into a multiplication problem. It happens all the time. Be super careful. So what do you mean? Rewrite your 3, rewrite your plus, rewrite your 4i, and now distribute your negative. -1 times 7 is -7. -1 times -2i is plus 2i. Notice I have dropped my parentheses so I don't accidentally multiply these. So now, again, I combine my like terms, my 3 and -7, and my 4i and my plus 2i. So I get -4 plus 6i. So let's look at multiplication. I'm going to do 2 examples of multiplication type problems. So first off, let's look at our Euler box method. So let's look at our 7 minus 3i, and this time we're going to multiply by 8 plus 5i. This is a problem you could FOIL or use box method. I'm going to use box method, but both techniques work perfectly fine. So across the top, I've got to write one of my factors. I'll write the 7 minus 3i. And across down the side, I write the other one, 8 plus my 5i. So now I'm going to multiply my row and column. So 8 times 7 is 56. -3 times 8 is -24i. 7 times 5i is positive 35i. And 5i times -3i is -15, careful, I squared. So often we have like terms on the diagonal, and I do in this problem. So I would write this as 56, and 35i minus 24i gives me a positive 11i minus 15i squared. So now you are not done, because we never ever write I squared as our answer. If you look back up at the top, we discussed the fact that I squared is equal to -1. So I'm going, instead of -15 times I squared, this is -15 times a -1. Well, -15 times a -1 is really a positive 15. This is really 56 plus 11i plus 15. Let's add my like terms, and I get 71 plus 11i. 71 being my real part, 11i being my imaginary part. I also want to talk about the distribution property, because that's also multiplication. So let's do a problem where we have to use that. How about -3i times 6 plus 7i? This is an example of a multiplication problem where I need to distribute my negative 3i into my parentheses. So negative 3i times 6, negative 18i. Negative 3 times 7 is negative 21, and I times I is I squared. So this is an example, like the one above, where I have an I squared. It's not negative 21 times I squared. It's really negative 21 times a negative 1, which is a positive 21. So remember, I need to write my answers with the real part first. So actually that positive 21 is going to go first, and my minus 18i will go second, my real part and my imaginary part for my complex number. So let's take a look at a few problems. The first problem I'd like to look at is simplifying number 7. Number 7 is an expression like you might get when you're solving the quadratic formula as you're getting close to the end. So what do? Well, the first thing I'm going to do is simplify the square root. Again, if you have trouble simplifying the square root of 40, please come see me so we can work on that skill. So in this problem, I'm going to work on my square root of negative 40. This is negative 1, and I'm going to think of this as 4 times 10. Of course, you can think of it as 2 times 20. But again, that would be why you'd come talk to me about how do we do it if I'm thinking about it as 2 times 20 if you're having trouble. So the square root of the negative 1 is I. The square root of the 4 is 2. I'm going to pull those out in front of the square root. And the square root of 10 is going to stay because I can't simplify that anymore. This is all over 6, but I'm not going to write it all over a single 6. We have been doing that. But now that I have an I in my numerator, I'm going to write it as negative 4 over 6 plus minus the 2i squared root of 10, the imaginary part, also over 6. I basically pulled my fraction apart so it no longer has that common denominator. I can now reduce this. Could you have before? Yes, but we don't write a complex number over a single denominator. That's why I separated it out. Again, come to office hours if you'd like more support with some of these concepts. So when I reduce by a factor of 2, my 4/6 reduces to negative 2/3. I can also reduce by a factor of 2, and I would get I square root of 10 all over 3. This is my final answer. It's really 2 answers. You're welcome to write it as 2 answers. It would be negative 2/3 plus I square root of 10 over 3, and negative 2/3 minus I square root of 10 over 3. So let's take a look at putting this all together using the quadratic formula. So on the next page, page 11, we have some problems where we're going to use the quadratic formula. I want to remind you, you still have to get your equation equal to 0 before you find your a, b, and c. And we need to remember that the square root of negative 1 is I. I believe you're going to have a negative under the square root in 21, 22, and 23. So let's look at 22 together. This one starts off very much like the problems we've been doing. My a is 3, my b is negative 5, my c is 10. And again, my quadratic formula is x equals negative b, negative 5 is positive 5, plus minus negative 5 squared is 25, minus 4 times 3 times 10, all over 2 times 3, which is 6. So to continue on, I get 5 plus or minus. Now 25 minus 120 would be negative 95. So this is the square root of negative 95 over 6. Now if you start to break down the square root of 95, 95 I believe is 5 times 19. So it doesn't break down at all. I can't simplify the 95 part. However, this is negative 1 times 95. I can bring the square root of negative 1 out in front. I can do the square root of negative 1. I get x equals 5 plus or minus I times the square root of 95. And just to save myself a step, I'm not going to write this all over 6. I'm going to write the 5 over 6, and I'm going to write the I times the square root of 95 over 6. This is my answer. It's really 2 answers. And yes, if I could simplify from my numerator to denominator by a factor of 6 or 2 or 3, I would. but I can't hear, so I won't be doing that. That would be my final answer. So if you're having trouble with these 2 pages beyond this video notes, please come to office hours or email me for a time, and we'll get together and look at the problems that you would like extra help on. See you in class. Thank you.